Hey everybody, Mr. Covey here, and in this video I'm going to go over polynomial mini quiz form A, and we go through the questions in order here so you can skip around to the questions that you need to get some help with here. So first, question says, if you fully factor this, you end up getting something that looks like this, excuse me, and the question is saying what is the Q, the P, and the C in this form. So we're going to factor this black underlined thing here. The first thing we got to do is check for a greatest common factor. That's always your first step with factoring. So if you look at that, what do all three of those have in common? You can use your calculator, I guess, to help you, but you shouldn't need to. They all have 3 and an x in them. You can take a 3x out of all of them. If you take a 3x out, 2x squared minus x minus 28. After you take out the GCF, you should look at this inside part and say, can I factor this anymore? I'm going to use the guess and check technique. So I'm going to know that my two factors, the first term in one of them is going to be 2x, the first term in the other is going to be x. And I'm just going to mess around until I get things that give me out a middle term of negative x. Okay, so I'm going to try stuff out. Here, I'll even show you. I'm going to put a plus 7 and a minus 4 there. And the way I'm going to check if that works is I'm going to look at the inner and the outer. Okay? So 7 times x is 7x. Negative 4 times 2x is negative 8x. 7x minus 8x is negative 1x. Okay? The reason I chose 7 and negative 4 to begin with was because there were two numbers that multiplied to negative 28. Going back to the question here, now that I have it fully factored, what's the Q? Well, the number out front in front of the x with the greatest common factor is a 3. What's the P? It's 2. What's the C? It's 7. Okay. Cool. Second question here. It asks you to describe the factoring process for this problem. Okay. Well, what's the first thing we always do when we factor? Take out a greatest common factor. What do those have in common? They both have a 3x. What are we left with? 4x squared minus 9. Okay. This can still be factored more. Why? It's two perfect cubes. Excuse me, two perfect squares. Okay? 4x squared is something squared, and 9 is something squared. It is a difference because they're being subtracted. What squared is 4x squared? 2x is 4x squared. What squared is 9? 3 squared is 9. Okay, we still have the 3x on the outside. Because this can be written as the difference of two squares, we can factor it to 2x minus 3 and 2x plus 3. That's called difference of two squares. You might remember it being called dots. Check. Which one of these says that? Take out a GCF of 3x and then use factor using difference of two squares. That one there. Third question here says, which of the following is incorrect? Let's be careful here. But upside down, I can analyze this and then see which one of these doesn't match easily. It's an upside down parabola because of that negative. X-intercepts at 1 and negative 3. Okay, let's see which one of these I can get rid of right away. Okay, that's true. True. It's got to be one of these ones. Y-intercept of 0, 3. How do you find a y-intercept? You plug in 0 for x. So if I plug in 0, I get negative 1 times 3 times another negative, that's positive 3. That's correct. So this one must be incorrect. The axis of symmetry is x equals 1. Why is that incorrect? Well, if you want to think about it graphically, I have an x-intercept at 1 and an x-intercept at negative 3. Okay? So an x-intercept there and an x-intercept there. The axis of symmetry is right in between the two x-intercepts for a parabola. So it would be at negative 1, not positive 1. So this is the incorrect statement there. That's my answer. Okay. Fourth question here says, type of possible function f of x in factored form for the following doodle graph. Okay. When you think about trying to determine the factors, you should be looking at the x-intercepts. I have an x-intercept of negative 3, 1, and 3. So since I have an x-intercept of negative 3, I need to put x plus 3 as a factor. Since I have an x-intercept of 1, I need to do x minus 1 as a factor. Since I have an x-intercept of 3, I need x minus 3 as a factor. Now the one thing to be careful about here is at that x-intercept of -3, I bounce, which means I need to have a squared on that x plus 3 factor. You could also have a 4th or a 6th degree or an 8th degree. You need to have an even degree on it. It has an even multiplicity, that's why it bounces. Okay. You could have also put a number out here if you wanted, just make sure it wasn't negative, because if it was negative, it would change the end behavior. Cool. Question 5 here. Just checking that for these different forms of a quadratic, you know what they tell you. Why they call it vertex form? It tells you the vertex. Factored form tells you the x-intercepts. You've emphasized that idea a lot. Factors tell you x-intercepts. That leaves standard form telling you the y-intercept. Remember, when you have standard form, it looks like this. Ax squared plus bx plus c. That number at the end, that constant that has no x attached to it, that's the y-intercept always. For question 6 here, you have to look carefully for the mistake. It's a little bit tricky to find. It is right here. So I found the super secret special number. I took my b, I divided it by 2, squared it. But when I added it to the other side, I wasn't supposed to add 25/6. I was supposed to add 25/6 times 3. Because remember, when I put this number in there, that 3 applies to it. So that should not have been a 25/6. It should have been 25/6 times 3, which is 25 halves. So I should have added 25 halves to both sides. And that would have changed then this and then that as well. Okay. Last question here. Which of the following situations is impossible? You have to think about the fact that the end behavior has to make sense here. Okay? So if you think about these different possibilities, the one that doesn't work out is this one. And the reason that doesn't work out is, well, you can think about continuity if you want, but third degree polynomials end behavior. Odd polynomials, degree polynomials end behavior is either up, down, or down, up. In either case, it's impossible to have a graph that starts down and ends up, or starts up and ends down. Kind of bad drawings, but let me draw a little better here. Starts up and ends down. Starts down and ends up. It's impossible to have a graph that has end behavior like that that doesn't pass through the x-axis at all. It doesn't have an x-intercept. It has to hit the x-axis at some point if it's going to go from the top to the bottom or the bottom to the top. Okay, that just has to happen. Think about even degree polynomials, like a second degree polynomial. That can have no x-intercepts. Why? Because its end behavior is going to be up, up, or down, down. It's possible that you have end behavior that's up, up, for instance, for a second degree polynomial. And it looks like that. That's totally fine. That other arrow is on the other side of the x-axis. There's no way to connect that arrow to the other one without crossing the x-axis. There's got to be at least one x-intercept. So this was the impossible one there. A little tricky question. All right, that concludes this video. Thanks for watching.